Hello grade 12 and welcome back to another video. In this video we're going to take a look at change in momentum as well as how to draw vector diagrams that relate the initial and final momentum as well as the change in momentum of an object. So to calculate change in momentum, we say change in momentum is equal to the object's final momentum minus its initial momentum. We can expand this to mv final minus mv initial. And since the mass of the object will be exactly the same, we can factorize out the mass, leaving us with v final minus v initial inside of the brackets. In some textbooks, you may see that they then say that the change in momentum is equal to mass multiplied by the change in the object's velocity. So each version of this is basically exactly the same. This is how you calculate change in momentum. And what is very important is that change in momentum is a vector quantity just like momentum, and therefore if ever you are required to calculate change in momentum, you must provide your answer with direction. Something else that is very important is that change in momentum, just like momentum, is calculated, or your answer should be given in kilograms per meter per second. Don't forget these important points. Let's now look at a question involving change in momentum. This question reads, Percy of mass 75 kilograms rides at 20 meters per second on a quad bike, that is a motorcycle with 4 wheels, with a mass of 100 kilograms. He suddenly applies the brakes when he approaches a red traffic light on a wet and slippery road. The wheels of the quad bike lock and the bike slides forward in a straight line. The force of friction causes the bike to stop in 8 seconds. The first question says, define the concept momentum in words. I'm going to leave that up to you. For now, I'm going to go on to question 2.2, which says, calculate the change in momentum of Percy and the bike from the moment the brakes lock until the bike comes to a stop. So very, very important here is that if we are calculating change in momentum, we must remember to choose one direction as positive and the other, of course, will then be negative. In the question, they spoke of forwards as one direction. That means the other direction will be backwards. Let's choose forward as positive. That means that the initial velocity at which Percy was moving will be taken as positive. We know that Percy comes to a stop, which means that his final velocity, or the final velocity of Percy and the bike, is going to be 0 meters per second. The mass of Percy and the bike will be Percy's mass plus the mass of the bike, which is 175 kilograms. We now have the mass, the final and initial velocity. So we can calculate the change in momentum by saying mv final minus v initial. Always remember to write down your formula. The mass is 175 kilograms. Final velocity is 0. We first write down the negative from the formula and then we plug in the initial velocity, which is positive 20. When we plug this into our calculators, we find that the final answer is negative 3,500. Now we need to write down our answer in the positive or as a positive value, but we must of course interpret this negative as a direction. So we say this is therefore 3,500 kilograms per meter per second. Grade 12s, please never forget your SI units. Since we chose forward as positive, we know that negative means backwards. This question is out of 4 marks. You'll obtain 1 mark for your formula, possibly 1 mark for substituting, 1 mark for the magnitude with the correct SI unit, and 1 mark for the correct direction. We often neglect vector diagrams in grade 12 because it is a concept that we study in quite a bit of detail in grade 11, and also because there are just so many concepts that you need to learn before the end of the year. But I have found vector diagrams come up in quite a few past papers, and I've therefore decided to include vector diagrams in this video. So, you might be asked to use vector diagrams to relate an object's initial momentum, its final momentum, and its change in momentum. We know that to calculate an object's change in momentum, we can say the final momentum minus its initial momentum. But in grade 11, when learning about vector diagrams and how to draw them, you learned how to make use of the tail-to-head method. And this is a form of vector addition. If you look at this formula, however, we are subtracting the initial momentum from the final momentum. And this is a bit of a problem. So how about we fix it by moving the initial momentum over? Then we have that the initial momentum plus the change in momentum is equal to the final momentum. This means that the final momentum will act as the resultant when we are drawing vector diagrams. So we will attach to the initial momentum the change in momentum using the head to tail. But then when we attach the final momentum, we will attach it from the tail of the first to the head of the last. To make better sense of this, let's take a look at an example. Here we have a car which has a mass of 1,000 kilograms. It starts off at a speed of 30 meters per second. This over here is the car's initial velocity. It then slows down to a final velocity of 13 meters per second. Now I've already done a few calculations for you. We have that the initial momentum is 30,000 kilograms per meter per second to the right, which we find by saying 1,000 multiplied by 30. The final momentum is equal to 13,000 kilograms per meter per second, and I calculated this by saying 1,000 multiplied by 13 meters per second. To calculate the change in momentum, I took the final momentum and subtracted the initial momentum, and I got the final answer to be negative 17,000 kilograms per meter per second, which is the same as 17,000 kilograms per meter per second to the left. So now that we have the initial momentum, final momentum, and change in momentum, we can draw vector diagrams. So we start off by drawing the initial momentum. My drawing will of course not be to scale, but here's the initial momentum, which is 30,000 kilograms per meter per second to the right. I'm not going to write down to the right because the arrow shows it. To the initial momentum, we are now going to attach the change in momentum. To the head of the initial momentum, we're going to draw the change in momentum. Okay, so the change in momentum is negative 17, so we're going to draw an arrow to the left. There is the change in momentum, which is negative 17, or we can just write down 17,000 kilograms per meter per second. And I'm not going to say to the left because the arrow shows it. Now, as mentioned, the final momentum is the resultant. So when we draw the resultant using tail-to-head methods, it is attached from the tail of the first to the head of the last. So now we take our arrow, we draw it in. As you can see, it points towards the right. Just as expected, this here is the final momentum, which is equal to 13,000 kilograms per meter per second. And this is how you're going to draw vector diagrams. You're going to be making use of this formula instead of the formula in its original form. So grade 12, this brings us to the end of this video. In the next video, we're going to be taking a look at Newton's second law in terms of momentum as well as impulse.